Hello. We're doing it. Question 52 and 53. If you're looking to see if you got them right, I got D as in dog and B as in boy. That's D as in dog and B as in boy. If you did not get that right, keep watching. So let's dive right in. This is an algebra question because it says the height of a woman is approximately normally distributed with a mean of 65 and a standard deviation of 2. So you immediately make a hump. In the middle you put 65 and you rate the first standard deviation, one positive standard deviation and one negative standard deviation, and it looks something like this. So what that means is, that because it says it's approximately normal, that means that on average, a woman is the height is 65 plus or minus 2 inches, which means that 68% of women fall between 63 to 67 inches in height. That is what that means. So the 68, 95, 99.7 rule sets the parameters for 1 standard deviation, 2 standard deviations, and 3 standard deviations from the mean. We use, if normal, the Z formula, AP statistics. So this is my formula, not on my formula sheet, but I take her actual height minus her predicted height, divide by the standard deviation to find a Z-score. The Z-score I get if I know the area under the curve. Well, they told me the area of the curve, because they said her actual height is in the 99th percentile. So what that means is that the area under this curve is 0.99 if the area under the whole curve was 1. That's what that means. So I pretty much know she's really tall. That's Rachel's height. And I'm looking for that value. So I can pretty much eliminate A, B, and C. So the only one that I'm not sure about is whether it's D or E. So if you know the area under the curve, the fastest way to do this is to use inverse normal on your fancy calculator. But let's say you can't remember that. So you'd use this score and you look in table A. So you look on table A, it looks like this. And you look for 0.99. So you just zoom in. All those numbers look really fuzzy, but you just zoom in until you see a number really close to 0.99, because all these numbers in here are the area under the curve. So I do that, and I see a number. It looks like the number 2.33. So the Z-score from table A, the Z-score from table A of an area of 0.99 or the 99th percentile, and that's the Z-score I get. And I'm going to make that equal to actual. Well, her actual height is what we're going to solve for, so I'm going to call that X, minus what we predict, so that we would predict a person to be 65 inches. That's what mean means, over the standard deviation. So ultimately, this is like an Algebra 1, Algebra 2 question. I cross multiply to solve. So 2 times 2.33 is 4.66, x minus 65. So after cross multiplying, I get that. And then I add 65 on both sides, and I get 69 inches, 0.66. Notice that would round up to 70. How would I could do that a lot faster? Inverse normal is when I know the area under the curve. So inverse normal is when I know the area under the curve. And this is a distribution question because it's normally distributed. So how could I have done this on my calculator? Get into your calculator, and go to stats, and distribution. Notice there it is, inverse normal. My area under the curve is 0.99. My average is 60. Average height of a woman, 65. Standard deviation 2. Bada boom, bada bing. I get an answer, 69 0.65. So I pretty much got the same answer calculating it by hand or on the fancy calculator. Both would give me the conclusion of 70. Next question. So how did I go about getting this answer? Let's take a deeper look. I kind of recognize this question. I'm wanting to go this times this, plus this times this, plus this times this, this times this, plus this times this, plus this times this, but I'm first going to read to see what they're looking for. So it says, assuming that Joe and Matthew make their decision independently, that's important, what's the probability they will purchase no books? And so I'm only looking for the probability of no books. So that would look like this. Well, the probability of 2 independent events is just multiplying the 2. And if this sounds a little confusing, you just think back to your dice. So if you're thinking about your dice example, you think to yourself, well, what's the probability of rolling a 6? It's just 1 in 6. I didn't roll a 6, I rolled a 2. And so you think about, are these independent? And you think, yeah, you know, this one can't, there's no gravity between these two. So the probability of rolling a 6 is the same. And so if they say, what's the probability of 2 6s? That's got to be 1 over 6 times 1 over 6 multiplied. So 1 out of 36 is the probability of getting 2 6s. We can understand this better if we write out a full chart. But that's the probability of getting 2 6s at the same time. And that's pretty rare. So that's why we get excited when we get a roll like that. So when I go back to thinking about, I'm not rolling a 6, I'm getting none. So the probability of getting none is 0.50, none from Joe, and none from Matthew. So using that same logic, I'm just going to multiply those two numbers together, and I end up getting 0.125. Thanks for joining us.